do this for those that are away. So we're deriving the special equations for kinematics. Equation number one, we're going to take our old friend A equals delta V over delta T, and I'm going to replace delta V with change in velocity is really what? Well, that's the final velocity minus the initial velocity. And I'm also going to just put T down there. I'm going to sort of just let the delta kind of just fade away. Usually technically delta T is TF minus TI, but 99% of the time, what's the initial time? 0. There are certain instances where that doesn't happen, but we sort of become accustomed to if there's a time interval, we know to just subtract. We don't get too excited about that, right? So we don't worry too much about the delta. It just kind of cleans things up a little bit. Okay, so now what I'm going to do is I'm going to take that and I'm going to multiply both sides by T. And what do I get? Right, I'm going to multiply both sides by T and I get AT is equal to VF minus VI. Okay, and then I'm going to take that minus VI to the other side, and I'm going to get a plus VI. And I kind of want, most people like their formulas to have like one thing on the left and everything else kind of on the right. So I'm going to take that whole thing, and I'm going to write it as, can you do it mentally? I'm going to take the minus VI over here, and it's going to become plus VI, and then the whole thing is going to be equal to VF. So then I'm just going to write it as VF equals, we put the VI first actually, VI plus AT. And that, my friends, is special equation number 1. The final velocity is the initial velocity plus the acceleration multiplied by the time. And it kind of makes sense if you think about it. The final velocity is whatever you started with plus the AT is how much it changed. How much it's accelerated by multiplied by how much time it's accelerated, right? It sort of makes sense if you sort of stop and think about it. That kind of solves some of those little nagging, two-step kind of things that we used to have to do, right? It was kind of a pain. Remember when I used to have to make you write delta V equals, and then you had the VF equals because sometimes it's 0 and sometimes it isn't. This kind of cleans all that stuff up. So that's equation number 1. Are we good? Pretty easy, right? Okay. Here's where the algebra level goes up considerably. This is known as equation number 2. Why, you may ask? It's the second one. Yeah, it's hard to believe. Now, I've been talking about this a little bit the last couple of days. Displacement is the area under a VT graph. This you know already. Displacement is the area under a VT graph. Guys, stop the side conversation. Seriously. Displacement is the area under a VT graph. Okay, so I'm going to draw you a graph here. There's the graph. And if I'm interested in the area between, the displacement between those two time intervals, this is time, and this is velocity, right? So if I'm interested in this displacement, I'm looking for the area of that shape. And what shape is that? You can look at it that way, triangle, rectangle. Is it a geometric shape, a single geometric shape that you recognize? And not many students see it, so don't feel bad if you don't. You don't know the name? Oh, yeah? Is that the exact trapezoid? Well done, Cheyenne. Most of the, oh really? Most of the time, oh, I have to do this. Most of the time, I have to do this and turn it sideways, and then even then, no, that's not a very nice straight line, but usually the trapezoid is drawn like this, right? Trapezoid means there's one set of parallel lines, and the other set isn't parallel. And most of the time it's drawn like this with them sort of out like this. I always think of it as the thing the elephant stands on at the circus. Although they're doing away with elephants at the circus, so that analogy won't work so much for kids in the future because they'll never have seen it. Yeah. Okay, now, next question. Does anyone know the formula for the area of a trapezoid? No, it's a single formula. Do you know it, Mia? Oh. Do you know the area of a rectangle? Length times width, right? Okay, so just stop and think about it for a second. If it's length times width, really the width, could we say that's the width? Okay, now the length is different, right? But like if I took that bottom and I kind of scrunched it and pushed out the top, or I guess one could say if I cut off this triangle right here and I put it like upside down over here, would that kind of give me, right? And what would be the length of this side then? Well, it turns out it's the average of the top and the bottom. Does that sort of make sense? Like if you average these two, if you scrunch the bottom in, push out the top, kind of average it, you got yourself a rectangle, right? So we would say the area of a trapezoid is side 1 plus side 2, that's plus side. Side 1 plus side 2 all over 2. The average of those top and bottoms times the height. That's the area of a trapezoid. Side 1 plus side 2 divided by 2. Average side times the height. No. You know what? All you have to do is write down and enjoy the derivation that you're about to see. Times height, yeah. Times height. Okay, now how does that relate to this one over here? Well, my width, remember I rotated, right? Guys, you got to watch. My width was this one here, right? And the width was the height, right? So the height is really this thing here, right? This is the height, which means that's the height. And what is that right there, that height? Well, that's the change in time. So I'm going to replace this times by height with a times by delta t. I get it. I get it's confusing. The end of this, you don't need to be able to do anything. All you need to do is sit and watch and enjoy. And try to get out of as much as you can. Well, maybe the enjoying part. The h is replaced by the delta t. Correct, Hannah. Oh, we're like 10 minutes away from that. Just sit back and enjoy the ride. Don't worry about having able to do this, you guys. That's not the point of this, okay? You don't have to do this derivation. Like, I'm not going to make you do it on your own. You just need to have seen it done. And there's more and more of this is going to occur, right? This is just the next step in producing a post-secondary student, is seeing formula derivations. And this is really the first one you've seen. So just sit back and enjoy the ride. Okay, so the h is replaced by the delta t. Now, we got S1 plus S2 divided by 2, right? So the S1 plus S2 were these guys here, this top and this bottom, which are the same as this one here and this one here, right? And it's the average of those. Now this right here, because it's a velocity time graph, this one here is really the initial velocity for this interval. And this one here is really the final velocity, VI and VF. It's important you're listening, right? VI and VF. So we're going to find the average of those. So that's going to be VI plus VF all over 2. So I've taken this trapezoid formula and I've replaced it, or I've sort of adjusted it to matching the values of this displacement under this VT graph. And that is equal to not the area, but the displacement. So in a sense, what I've done is I've taken this area of a trapezoid formula, converted it to displacement and velocity time. Okay? Everybody sort of with me to that point. It's okay if you're not 100% there. Again, it's about the experience. Okay? Think of it as bungee jumping. You're probably not going to do it again. But it's going to be fun. Without the fun part. Okay. So now, here's the part that everyone hates. I'm going to take out this half. Instead of divide by 2, I'm going to write it as d equals, like dividing by 2 is not the same as multiplying by a half. Okay, so I'm going to write it as 1/2 times, and advanced academics like to use a little dot for times, because x is like for kids. So it's 1/2 times vi plus vf. And again, I'm going to let the delta t just sort of become t. Because we know that we mean time interval, because it kind of cleans things up a bit. Some books like to leave it in. I prefer not. Okay. You might think you're done. Not yet. Oh, yeah. Okay, so now what I'm going to do is I'm going to take special equation number 1, which is VF equals VI plus AT. Yeah, eat a meal, right? I'm going to replace the VF in the equation with VI plus AT. So over here, now I'm going to write this as D equals 1/2 VI. Now that VF was, and I'm going to put it in a different color for you. Special equation 1, VF is now VI plus AT multiplied by that red T that was already there. What step did I just do here, Renee? Right? Remember, this VF is now becoming VI plus AT, right? So this is the original red VI. This red VF has become, in black, VI plus AT. Okay? And I promise this is almost the end here. Now it's just a matter of sort of cleaning it up. Right in the back. It's okay. You know what? You're not the first, nor will you be the last. I accept your apology. VI plus VI, we can write that as 2VI plus AT times T. And now the last step, combine it all together. It's 3 things multiplied together, right? Yeah, so I'm going to multiply it all together. I'm going to take 1/2. Now when I multiply it all together, I got to take the half times the t, and then I got to multiply that. I got to distribute it, multiply it by this one, and then I got to multiply it by this one. Again, you don't need to be able to do this. At the end, you'll have a formula that you can use. You just have to go through this experience. Yeah, yeah. I thought I was clear, but I guess I wasn't. You don't have to do this every time. You just need to go through this ordeal. It is. Oh, wait till the next one. Let me finish. Can I finish that? Okay, so 1/2 times 2VI times T is going to give me, 1/2 times 2VI is going to give me VI, right? 1/2 times 2 gives me 1. VI multiplied by that T, so I get VIT. VIT. Then I got to do the other one. So 1/2 times AT times T, 1/2 AT squared. And that, my friends, is known as special equation number 2. This is the one that cleans up all those problems where you had to do 2 or 3 steps. Remember having to convert to average velocity and all that stuff? Yeah. Gone, thing of the past. Use this. See, that's the benefit to going through the ordeal. Now, if you stop and you think about it, really, Like, if you just imagine, I'm just going to kind of cover up. I'm going to make a little kind of boxy thing here. Just going to fill it in so you can't see it. How do I fill? Properties. Okay. If I just cover up this part of the formula, what does it say? D equals VI, or D equals V times T, right? Displacement is velocity multiplied by the time. And you already know that. Velocity multiplied by time is the displacement, if the velocity stays the same. So this part of the formula is the displacement if the velocity were to stay the same, plus the distance you cover if you are accelerating. This is the I'm moving at a constant velocity part. This is the plus I'm also accelerating. That's the way I sort of think about it. Okay, so you can now use, you now have a license to use D equals VIT plus a half AT squared. Don't you dare teach to any grade 11s. Okay? It's our little secret because they got to go through all this stuff. Did anyone teach this to you? No. Last year's grade 12 kept the secret. You guys have to keep it as well. You're a special club. Because you didn't know how. Could you have done this last year? You guys couldn't even find the equals button on your calculator last year. Okay, I hate to tell you this, equation 3 is about 3 times as complicated as equation 2. So be ready. Yes, ma'am. Pardon me? Are you going to what? This is the last one. I would suggest starting a fresh page. Yeah. If you get a half page, you're probably going to go on to the next page. This is a big one. More than that. There's fractions here. I always suggest starting on a fresh page. Even then, it might not be enough. Okay. So, I'm going to, I know that I'm starting to lose you. Hang in here, you guys. Just one. Again, you don't need to do this. Take equation 1 and isolate T. Take equation 1 and isolate T. So we're going to take VF equals VI plus AT, and we're going to write it as T equals. Now, some of you can probably do this mentally in your head. Some of you probably can't. That's okay. To get T all by itself, what do I have to do? I'm going to take that VI to the other side. VF minus VI, and then I'm going to, how do I get rid of the A? Divide by A. So T equals VF minus VI. Over A. Okay, now we're going to take this and we're going to plug it into equation number 2. Why would you do that, Mr. Ben? We're trying to create a formula that doesn't have time in it. That's the idea here, is to create a formula that doesn't have time. Remember this, Miguelski, how much fun deriving these equations were back in grade 12?
You know what, this is university stuff. Like, this is what you do in university. You don't do other equations. It's just like formulas. No answer.
This is just your first, this is just like into the wading pool, you guys. It's your first experience. That's what we're doing, is we're making them here. Right? They want you to understand where they come from. They want you to understand that formulas don't just fall from the sky and that's the way it is. Why is that the way it is? We're explaining why it is. Okay? So it's really just an appreciation. Okay, Braden, here we go. I'm going to take this T and I'm going to plug it into equation number 2. Now I'm going to write equation 2 in blue. Equation 2 was, that we just finished, D equals VIT plus 1/2 AT squared. Now, do you see what's coming? I'm going to take this fraction and I'm going to plug it into there for T. And that's going to eliminate the T's. But it's also going to make it...
You can let it out. It's all right.
Hey, I got no problem with this. I love this stuff. This is awesome.
6 weeks suspended.
Okay. Okay, back to this. Back to this. Smalski, back to this. Okay, so what I'm going to do for you is I'm going to write the T in black, okay? So in blue, I'm going to write D equals VI, and then now this goes in for the T in black. VF minus VI all over A. Everybody see what I did? This right here, which is equal to T, is going in right here. Okay? And now I have to do it again over here, and this time it's squared, just to make it fun. 1/2 A T squared VF minus VI all over A squared. Now, I guess you could probably leave your formula like that if you want. Yeah, you don't want that, so we're going to simplify it. We're going to have to go through a lot of ordeal and some pain here, but it's going to be simple at the end. Stick with me, I know what I'm doing. Okay, now let me just check my notes. I know what I'm doing. Okay, so now I'm going to multiply this VI into this bracket. Taking VI and I'm going to multiply it into that bracket. And I get, should I put it in blue? Yes. That's okay, you don't have to change the color. It's just more for visual for here, to understand what's going on. So I'm going to write VI times, it's going to be VI VF. VI times VI is minus VI squared. And it's all over A. Well, I checked my notes, only because I've gotten off path a little bit, a couple times, right? But I know how to do this algebra. I have a math major, Renee. Like, I mean... No! In 10 years, remember what the video said? In 10 years, you'll, like, I mean, you're going to change. Like, this is... Why? I guess there's... I sort of have a certain... I find this sort of... I wouldn't say relaxing, but there's a certain art to it. Like, it's kind of elegant in some ways. And it's hard for people to understand that, I know. But it's no different than someone appreciating music or art or athleticism. Well, I appreciate how it all sort of fits together. Yeah. I draw the line at that. I'll watch it on TV, but not radio. I tell you, right in the back again. Hurtful. Okay. So, what should I do here? People that appreciate math. What should I do? Let me check here. Oh, yeah. Can I multiply this in, or should I do the squaring part first? Got to do the squaring part first. But I will do this. Can I take the 1/2 A, 1/2 times A, and write it as A over 2? Can I do that? Okay. Now, do you remember how to square a binomial? I know Mr. Ray teaches this. Yes, don't give me that hand. If I walk down there, he'd be mad at you. X plus Y squared? X squared plus 2xy plus y squared? Yeah? Right? Remember that? No, you don't have to write that down. Okay, so, but I got to do that with this one. What if it's x minus y? Well, then it's going to be x squared minus 2xy plus y squared. So now this is going to become, oh, I said I'd keep it in blue, wouldn't I? Doesn't matter. Does it matter that it's in black? No. Good? Okay. So it's going to be VF squared. It's a minus, so it's going to be minus 2, what? We always put it sort of in alphabetical order. We're going to call it VI, VF, which you'll note is the same as this over here. Minus 2 VI, VFs plus a VI squared, and it's all over. I told you you needed a fresh page. A squared, Braden. You have to square the bottom as well. It's okay, man. Okay. VF squared minus 2VIVF plus VI squared. Alrighty. Now, I can take this A over 2, and I'm going to multiply that in over here. It's okay. Do you see the A on top? Guys, stay with me. Do you see the A on top and the A squared on the bottom? Right? Cancel a little. Because I've got one A on top, and I got A times A on the bottom, so I cancel an A on the top and an A on the bottom, and I'm left with a single A on the bottom. Good question. Okay, so now I got VI, VF minus VI squared all over A, plus, so now all I really have to do is take that 2 in on the bottom, right? Well, this step is actually fairly easy. So now it's same thing on the top, VF squared minus 2VI VF plus VI squared, and it's all over 2A, right? The 2 in front. 2A. This is exactly the same as that. VF squared minus 2VI VF plus VI squared, all over 2A. Now, how do you add fractions? Common denominator. Very good, Will. What's the denominator here? A. What's the denominator here? 2A. Can we add them? No. We have to multiply something by 2. Which one do we multiply by 2, Shelby? The one on the top and bottom by 2, right? Awesome. Okay, so, well done. So top and bottom by 2. So this is going to become 2VI VF minus 2VI squared all over 2A. And what happens over here, Renee? Anything? So unfortunately you have to rewrite it, which sucks, but VF squared minus 2VI VF plus VI squared all over 2A. Now you can add them, Will. Excellent. So the whole thing is all gonna be over 2A. Just wait till first year calculus, you guys. It's gonna be awesome. I made the mistake. Okay, so we're gonna add together here. So now, has anyone spotted ahead here, looked ahead and seen any cancellations? 2VIVF minus 2VIVF. See you later. Now I've got a minus 2VI squared, and here I've got a plus VI squared. So minus a VI squared, right? How many people want to have that out front? Nobody. So can I write the minus VI squared over here? Minus 2VI squared plus 1 VI squared gives me minus 1 VI squared. And now I'm left with? Hey, look at that.
Not bad.
Oh, what do you know?
You're scaring us.
Yeah, I like to scare people.
That was extremely aggressive.
Hey?
That was extremely aggressive.
Yeah? Now, generally, we don't leave it like this. You can. I've seen it in books like this, but usually we write it with the BF as sort of the thing that it's equal to. So I'm going to take the 2AD and it's going to go up here. Okay? And I'm going to have, yeah, this part's just like cleaning up. 2AD. 2AD is equal to VF squared minus VI squared. The VI goes over to the left, and you end up with VF squared equals VI squared plus 2AD. And look at that. All that work, and that's what you get. You take the 2A up here, multiply both sides by 2A. This, my friends, is special equation number 3. You have the license, because you've been through all this, now you can use that formula.
There's no 4.
Why is it BFF
Why is this not a minus? Well, this really becomes, Blair, this really becomes, I shouldn't put in equals. This is really 2AD. The VI goes to the other side and becomes VI squared plus 2AD is equal to VF. And then once I do that, then I just, right? I just write it the other way. Because everyone likes the one thing on the left, that's all. Good question. Was that an ordeal? Absolutely, yeah. It sucks. Wait till we get to the circular motion formulas and I do that again. I'm going to do this derivation thing about 3 or 4 more times. Again, you don't have to do it. You just got to sit through it and, okay, yeah, okay. That's where the formula comes from. That's all the point is.
Do we deserve an X-ray?
Do you deserve a what? Oh, well, how about every once in a while I get a round of applause, but, call it quits? It's like when I was driving in Sting. My last thing. No derivation, I promise you. Remember this? It's just something you need as well. You just need to know this formula. I'm not going to derive it. You need one single line, like an inch of paper. Remember this? No, because this has a special name.
Oh, I was so good.
Remember this? Quadratic formula? Minus b plus or minus the square root of b squared minus 4ac all over 2a. Remember that? Would you like to see the derivation? You don't want to see it. Yeah, that's the end right there.
What's the point of this?
You remember, when do you use this? When you're solving for 2 zeros, right? You're solving for this. There are instances in physics where you have to solve a quadratic, and the best way to do it is with the quadratic formula. So I'm just reminding you that you know this already. I'm not deriving it. I don't need to. It's not in the curriculum. Maybe in math they derive it. I don't know. Or do they just give it to you? Yeah, that's what I figured. Okay? If you're really interested, go and Google it. I'm sure it's there somewhere on YouTube. Okay, so after all this, you now have, look at all that. Isn't that awesome? Should leave that up there for grade 11, just to scare them, right? If you walked in for a grade 11 class, like the second week of school, and you saw this, and I said, oh yeah, that's grade 12 physics. Yeah, so I'm not doing it, because I want to make sure I have a job next year. Yeah, we'll get to this next week. Yeah, test on this next week. So you have this formula, you have this formula, and you have this one here.